So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass coder this side. So we are going to solve the question merge to BST in this video. The problem is actually simple. You have been given two BST. What do we mean by BST? A binary search tree. Let me elaborate it. Binary search tree is a simple binary tree which follows the following property. What is the property? That for each node, the values in node left subtree are less than the value of node when it is in turn the less than values in node right subtree. Okay, I guess I'm clear with it. So the values in the left subtree should be less than the node, and the values of the node should be less than the values in the right subtree, and this should be followed for each node. Okay, so you can validate the BSTs here. So you can see that 12 is actually greater than 9, 9 is actually greater than 6, 9 is actually greater than 11, and you can also see 12 is also greater than 11. If this would have been 13, if this 11 would have been 13, then this would no longer remain a BST. Why? Because 12 is less than 13, so that is not possible. So this would have not been a BST. Instead of 11 it would have been 13. Similarly, you can see that 11 less 5. Now 5's right is 8, which is greater than 5 but less than 8. 11, 8's right is 10, which is greater than 8 and 5, but it is less than 11 as well, so it is also a valid BST. These two are valid BSTs, right? Now the process is to merge them. How to merge them? We don't have to merge them on the basis of nodes. You just have to return with a sorted array. Right? How do I return the sorted array? Suppose I make an array, right? I see both the trees. I see which value is the smallest among these. So you can see in the left subtree 6 is the smallest value. In the right tree it is 5 is the smallest value. So I will say 5 is my first value. Moving forward, you will say 6 is the smallest value from this tree, right? Now moving forward, I will be able to see that after 6 here comes 9, but here comes 8. 8 is smaller, so I will say 8. After that 9, after that 10, after that 11, followed by 11 again. First this 11, then this 11. You can choose any order, 11 or 11, right? Same. After that 12. So you can see this is my sorted order. This is the merge. This is the merge of two BSTs. This is the merge of two BSTs, right? You just have to do this. You just have to run this vector which contains the values of the BSTs in a sorted order, right? So what is the brute force approach? What is the brute force approach? Okay, so the brute force approach is simple. I think that they are not like BSTs are also a form of binary tree, right? And in the binary tree, I have got traversals. So what will I do? I will just traverse both the trees. That is, traverse first tree in any order. You can do pre-order, you can do post-order, you can do in order, you can do level order, any order. Traverse first tree and store elements in an array. Store elements in an array. Let us name this array as array 1, ARR1. Similarly, traverse second tree and store in ARR2. The same step. So you can make a function out of it, right? Now merge them. Now merge them. How do we merge them? We create a fourth array, or this is a part of 3A only. So third array, which will be our answer array, push all values of ARR1 and ARR2 into answer, like push all the values firstly and then sort answer array, right? How do you sort? You can use a STL, that is sort answer dot begin comma answer dot end, and that will sort your array and return this array. Return answer. As simple as that. As simple as that. Right? So what is actually happening? For these two trees, my array 1 and array 2 will look something like this. If I'm following the pre-order traversal, my array 1 and array 2 will look something like 12, 9, 6, 11. This is my array 1, and my array 2 will look something like 11, 5, 8, 10. Right? Now I will make third array which will contain 12, 9, 6, 11 in the same order, then 11, 5, 8, 10 in the same order, and when I will sort it, it will look something like this. When I will sort it, it will look something like this, and this is my correct answer. Right? Now what is the time complexity to solve this? So first we took a O of n time complexity to create array 1, plus O of m time complexity to create array 2, plus O of n plus m time complexity to create array answer because we are pushing the values there, plus O of n plus m log of n plus m to sort it. Right? So my greatest time complexity is this one. So my answer is O of n plus m log of n plus m. But this is the brute force approach, right? This is the brute force approach. Now if I try to optimize it, the arrays I have in hand is 12, 9, 6, 11, 11, 5, 8, 10. 12, 9, 6, 11. Let me write it down. 12, 9, 6, 11, and 11, 8, 10. 11, 5, 8, 8, 10. 11, 5, 8, 10. These are the two arrays I have in my hand, right? I have in my hand. Let us suppose, by some miracle, these two arrays are sorted. These two arrays are sorted. That is, the array 1 is something like 6, 9, 11, 12, and the array 2 is 5, 8, 10, 11. Right? Okay, now will it be easier for me to create an answer array in already the sorted order if I know that array 1 is sorted, array 2 is sorted? This is my array 1, this is my array 2. I know that both of them are sorted. This is my answer array. Is it possible to me that I will insert the elements from array 1 and array 2 in the sorted order rather than sorting the answer afterwards? Right? I don't want to use sort library. I don't want to use sort library for answer. That is a big no for me. So what can I do? I know this array is sorted. I know this array is sorted. There is a popular technique of merging two arrays, which I have also explained in one of my videos. I will keep two pointers here, I here, j here, and what will I do? While my I is less than my this length, while my j is also in my inbounds, what will I check? I will check if 6 is less than 5. No, 5 is less than 6, right? So pick out. So 5 will come here, and because I picked out 5, j will come now here. From 6 and 8, 6 is smaller, so pick out 6. Because I picked out 6, I will come here. From 9 and 8, 8 is smaller, so 8 will come here and j will come here. Right? J will come at 10. From 9 and 10, 9 is smaller, so pick out 9, I will come 11. From 10 and 11, 10, j will come here. From 11 and 11, I. Or you can choose a j also. Let us suppose we choose j. So j comes here and I push 11 into it. I remains at 11. I is here, 11 and 12 are still finished. So I will just make a loop until and unless my I reaches the end. So what will I do? I will say for the two elements 11 and 12, just push them. Right? 11, after 11 pushing I will come here, after 12 pushing I will come here, and you can see all the elements are inserted into my answer array, plus the answer array is sorted, plus the answer array is sorted. What did I achieve here? Given that these two arrays are sorted, I achieved that this array was made in O of m plus n time complexity in sorted order. This is also sorted, and it was made in m plus n time complexity, which was taking a time of m plus n log of m plus n, right? So I actually saved some time. I actually saved a lot of time. The actually time complexity went from n log n to O of n only, right? This is a good transition. This is a great transition. Now, I want to ask, is there any way such that these two arrays are received by me in the sorted order? In the sorted order. So what can I do for that? So initially I said that BST is also a binary tree, but traversals, right? So traversals are also part of BST. Now let us take the BST example. Suppose this is a BST. I'm not filling the value. Suppose this is a BST, right? This is a BST. Let us say A, B, C, D, E, right? I also know that left subtree is less than node, less than right subtree. Now I told you that you can take any traversal, right? You can take any traversal. In the pre-order traversal, what happens? You first explore the route, that is, you take the route value, then you go to left, then you go to right. In the in order, what you do? You go to the left, you go to the route, you go to the right. That is, first explore the left one, then come to route, then come to right. After that, what will happen? What is post? So you say first right, left, first right. That is both children first, and after that route. Okay, no problem. Keep your eyes on in order, guys, for a minute. Focus yourself on in order for a minute. Left, root, right. Again, I'm repeating left, root, right. Left, root, right. Left, root, right. Are you able to see that? If I'm going from this node, first I'm exploring this one, then I'm exploring this one. After exploring this one, I'm going to the node, and then it will come back, and then I'm pushing D into the answer array. Okay, it will go to the right node, come back, it will go back, and after coming back from the left one, it will push B into the answer array. After that, it will go to the right tree, it will go to left, that is null, returning, then it will push E, null. After that, it will return and it will go here, and A will come here. A will go to C, C will say okay, it is null. Because it is null, I will push C myself, and then it will be done, right? The recursion call is done, and I got the answer. I got the array one as DBAEC. Am I asking that DBEAC is always sorted? My conclusion is that DBEAC is always sorted. Why? Because I know D is the smallest element, because it is on the leftmost. D is the smallest, right? Above D, it is gonna be B. Why? Because B is less than E and B is less than A. So B has to come here, right? E is less than A and E is greater than B. So E is coming here. A is less than C and it is greater than E. So coming here. Then C is the greatest. We know because it is the rightmost node, right? Okay, so this is done, right? I hope this is done to you. That in order of a BST is sorted. The in order of a BST is sorted. This is a very important property. Just mark it out for yourself, right? It will be used in many questions of the BST. In order of a BST is sorted order. So this solves my problem of getting the array 1 and array 2 in the sorted order, right? Because we know in order we will get the sorted order, and we just made the merge out of them in O of m plus n time, right? So this is the approach, right? First in order array 1 contains all the element. In order array 2 contains all the element. Merge. This is the only operation. It will take O of n time, this will take O of m time, and this will take O of m plus n time, right? I hope that is clear to you. Now let us move to the code. Alright guys, so here is the coding section. But before proceeding with the code, I would like to request you to please subscribe to my channel, because it really means a lot to me, right? Okay. So our first step will be to create two arrays to store the answer. So vector of int arr1 and similarly arr2, and similarly make an answer array also. Then call for the in order of root 1 with arr1, and then after that call the in order for root 2 arr2, right? So let me define the in order function first. So void in order, which is taking a parameter of node star root, and it's taking one of the vectors by reference, right? Now if root equals to null, simple in order function, return. We can't do anything. Now if it is not null, first explore its left, then in order of root left answer, then push the value. So answer dot push back root data, and then go for the right part exploring. So root right comma answer, right? And after that simply return. This will give me the two arrays in the sorted order. Now just have to merge them. So int I equals to 0, similarly j equals to 0. Now while my I is less than arr1 dot size and my j is less than arr2 dot size, what will I do? I will say if ARR1 of I is less than equals to ARR2 of J, answer dot push back ARR1 of I plus plus. Just increment the pointer. Else answer dot push back ARR2 of J plus plus. Right. Now simply do for the unvisited elements in one array, because either I will be have finished or J will be have finished, and some unexplored elements would have remained in the arrays itself. So I less than ARR1 dot size. What will I do? I will just say answer dot push back ARR1 of I plus plus, while J is less than ARR2 dot size. Answer dot push back ARR2 of J plus plus, and simply after that return the answer. Return the answer. Let us try to compile and run it. Hope it will work fine. Should not give any error. It is working fine with a sample test case. Let us try to submit as well. So as you can see, it is getting submitted and my current streak is 221 days. Thank you for watching, and we'll meet in the next video. Till then, stay tuned and keep coding. Thank you. Have a nice day.